Welcome to Mastering Solutions. What we have to do is they give us the min and the max for the wavelength, so the extreme ends of this white light diffraction grating. The diffraction grating is splitting out all the different colors, so you'll see all, that's why they say there's a rainbow. And so we have to figure out what is the minimum and the maximum, or blue and red, and the difference in the width between those two will give us the total width of this. So in order to find those, we're going to use a very similar process as the last question that we did. So to find those two y's for the blue and the red, we're going to use a similar process that we did on the last question. I like to think about the big overall picture of what we're doing. And so at first, we're going to use the equation y, or we'll come to it. This is what we're trying to find, the y for the red and the blue. And that equation is L times the tangent of theta, but we don't have any degrees given here. So we have to solve for that before we can figure out the y. To get it, we're going to use sine of theta is equal to m times lambda over d. So once we figure out theta, we can plug it into here to get the y for both of those. So first we need to isolate theta. So we'll just take the inverse sine of both sides. So theta is equal to the inverse sine of m times lambda over d. Okay, now this is ready to go. So let's start with the 400. So 400 nanometers, and that's blue, of course. So theta is equal to the inverse sine of m, which we're going to use the first order. So 1 times lambda, we said, is 400 nanometers, 10 to the negative 9 meters. Now, what is d? The d is always equal to the width over the slits or the lines. And here we have 1 millimeter, so 1 times 10 to the negative 3 meters over 600 lines or slits. So we can just plug this whole expression in right here instead of calculating a value. I find it's a little bit more accurate to do that, so we don't have to worry about any rounding errors. Over 600 lines. So if we go to our calculator, we have the inverse sine of m, and we're using 1, and then we're multiplying that by lambda, which we said in this case is 400 times 10 to the negative 9, and that is divided by 1 times 10 to the negative 3 divided by the lines, which we said was 600 for this diffraction grating. So our angle, and make sure you're in degree mode, otherwise you'll have to convert the radians into degrees, and it's easier just to change your calculator to degree mode. So our angle here is 13.89 degrees. So we have 13.89 degrees for the blue. Now let's do the same thing for the red, the 700 nanometers. And that is theta is equal to the inverse sine of 1 times 700 now nanometers, and then divided by d, 1 times 10 to the negative 3 meters over 600 slits or lines. And in our calculator, it's pretty easy because we can just go in and copy this forward, and we'll just change this to 700. Everything else is the same, of course. So the degrees for red in this case is 24.83 rounded. So we have 24.83 degrees for red. So now that we have the degrees for both the red and the blue, now we can do the same thing over here. We'll use the L, which is 2 meters in this case. And let's figure that out. So y for the blue is going to be equal to L, which we said was 2 meters, times the tangent of the angle, and that's 13.89 degrees. And then we'll have the red. I'll just write it out real quick since we're here. 2 meters times the tangent of, in this case, 24.83 degrees. So we have 2 times the tangent of 13, and that is going to be and that's meters. Let's do it in centimeters. So 49.46, and that was for the blue. So we have 49.46 centimeters. And then for the red, We have 2 times the tangent of that angle, which we said was 24.83. So we have 92.54. So 92.54 centimeters. So now this is the distance from the central max out to the blue fringe and the central max out to the Y fringe. But that's not what we want. We want the width of the whole rainbow on the screen here. And since this is the minimum and the maximum, if we take the difference between the two, that will give us the whole width, of course. So we have 92.54 minus 49.46. So 92.54 centimeters minus 49.46 centimeters. So the total distance, we'll round that down, is 43 centimeters for the whole width of the first order rainbow for this diffraction grating.